Hi guys, so our goal is to make the function for a rational given the actual graph for it. And as you can see probably now that you're looking, there are like 10,000 YouTube videos for it. So if this one doesn't help, there are many more resources you can go. But as we normally do, we're going to check our vivid steps, VITH, which each one represents something that we're going to have to find on the graph. So the first V is the vertical asymptotes. So we look at our graph, there's only one at x equals 2. So we're going to put an x minus 2 in the denominator to force it to have that undefined value at x equals 2. Second thing I want to check if there's any volcanoes. So that's checked off. Volcanoes being that our end behaviors are going the same direction around that horizontal asymptote. So on the left side of it, it's going up. On the right side of it, it's going up. So that is a volcano. Makes that volcano shape. So when we have that, we're going to square that factor. Thirdly, we have to look for x-intercepts. So in this one, there's an x-intercept at -2, so I put a factor of x plus 2 in the top. Here I also have a factor of 1. And those are all my x-intercepts. Then fourthly, I have to check to see if any of those x-intercepts touch the x-axis and then leave. So this one at -2 is going through the x-axis. It could have some multiplicity, but we're not going to go into that too much further in 3x, which you will go into in 4x. But eventually, we are going to have a touch here at 1. Notice that it comes in, touches that x-axis, and goes back out. So that factor is going to be squared. So we have one x-intercept that touches. Lastly, if we're looking for horizontal asymptotes and holes. Now, with my equation right now, I look at the situation on it in that the top has a degree of 3, and the bottom has a degree of 2. So the degree is bigger on the top than the bottom, which is actually good for my situation because, as you can see, I do have a slant or an oblique asymptote. So the degree has to be bigger on the top. To check where that asymptote is, we're going to do our long division. I'm just going to show the work on how we would have to expand this. That we're going to do the x minus 1 squared first, just to keep our order of operations. So I have x squared minus 2x plus 1. I'm going to multiply that whole thing by that other x plus 2. As you can see, then we have x cubed minus 2x squared plus 1x. We're going to multiply everything by 2, which will be a 2x squared minus 4x plus 2. So in my long division, I'm going to have that underneath. Bars here. I'm going to simplify it as I put it in here. I have x cubed. Now I have a negative x squared plus a 2x squared, which is very important to keep a 0x squared for that place value, just so you're subtracting the same coefficients with those same x squareds. And then eventually I have a, let's see here, x minus 4x, which is a negative 3x. And then it looks like just a plus 2 at the end here. And I'm dividing it by the expansion of this, which is x squared minus 4x plus 4. So we'll go through those same steps that we normally ask ourselves. We're going to multiply this by to get that lead term. In this case, I'm going to multiply by x. So I get x cubed. I get a negative 4x squared. Then x times 4 is a positive 4x. At this point, we're going through our subtraction. We have to be very careful that an x cubed minus an x cubed is obviously 0x cubed. But I think where we get lost a lot of the times is that we have to think of that as 0x squared minus a negative 4x squared, which does become a plus. So that is a positive 4x squared. Same thing here, a negative 3x minus a positive 4x is a negative 7x, and I'll bring down my plus 2. Keep going with our division. Thinking about what do I have to multiply this by to get that lead term, which is a positive 4. So I get a 4x squared, negative 16x, and then 4 times 4 is a positive 16. So from here, I get a 0x squared, I get a negative 7x minus a negative 16x, which is a 9x, and a 2 minus a 16 is a negative 14, but in fact, I've noticed that my degree is kind of lower than my divisor, so in this case, this will be my remainder, but with what we're dealing with, we're just going to ignore that. With my equation, how it is right now, I have my slant asymptote at y equals x plus 4. So I go back to my actual given equation for what this slant asymptote is. It's got that y-intercept of 8, does have a slant or slope of 2. So right now my equation isn't good enough, or it doesn't fit where that slant asymptote needs to be. So I think about how I can adjust this. Now I notice, x plus 4, how do I get it to a 2x plus 8? And it looks like I'm just going to multiply by 2. But I got to think about what that does to my long division over here. So think about that if I did multiply this whole function by 2, for example, if I put 2 out front here, well, that would change all the terms in this expanded form. It would start to look like 2x cubed plus still a 0x squared, but then it would be a negative 6x, and then it would be a positive 4. On the outside, it wouldn't change, actually. It'd just be an x squared minus 4x plus 4. So I see, noticing that now when I multiply that front term, I get a 2x. And look what happens underneath. I get a 2x cubed. The 2x times the negative 4x is a minus 8x squared. And then I have my 8x, which actually won't come into play too much, because if you notice, these are gone. The next subtraction gets me an 8x squared out front. So I'm just going to ignore this stuff for time. And notice my next multiplication is going to be a plus 8 to get an 8x squared. So that's how I can change my function to fit this horizontal asymptote. And if you checked in your calculator, my function rule would be f of x equals this whole big irrational here, 2 times x plus 2 times x minus 1 squared all over x minus 2 squared. So hopefully this helps with the slant. You do want to get your degree bigger, but then you have to check with the long division to see where your function is, and then you might have a multiplication to adjust where that slant asymptote or oblique asymptote has to be. Hopefully this helps, and good luck with this. We'll see you guys later.